We are looking at 6 different exercises. Exercise 1 begins by keeping your hand horizontally. You can see like this, and your palm should move up from there gradually so that it is completely vertical at the end of the exercise. The second exercise is starting from horizontal, and then it moves down, the palm moves down, finally coming to rest in a position like this. The third exercise that we are talking about is starting from this horizontal point, your palm pointing downwards, and then it is gradually flipped upwards. The fourth exercise will be starting from the upright position like this itself. This is your starting state, and then you flip inwards so that it comes to rest with your palm pointing downwards. The fifth exercise is when your palm is starting from a horizontal position and it moves towards your body. This is your fifth exercise. As you can see, this is staying to the in the horizontal axis itself, but it is moving in a direction that is towards your body. Then the sixth exercise is when your arm starts from the horizontal position and then your wrist is rotated so that it moves away from your body. So these are the 6 possible exercises that are carried out. We have carried out multiple such exercises, and the results that we have got from this are plotted in the graph that you can see here. However, there were some variations, so we have taken an average of all those readings and taken that as the mean of the responses. So this will be how the waveforms should look like for each of these exercises. And as you can see, each of these exercises exhibit different waveforms. These are the readings of the accelerometer. So when you carry out the exercises, you get totally different sets of readings. And based on this, you can not only distinguish between the exercises, but you can also track how the exercise is progressing. The x-axis is in duration. 60 is the number of samples, which is like 10 samples per second is the sampling rate that we have taken. So if your duration is set as 6 seconds, you will have 60 samples. If your duration is 10 seconds, you will have 100 samples. So just by looking at the average waveforms and comparing it with the waveform that you receive when you are carrying out the exercise, you can track your progress. Ideally, as your progress improves, you should be able to perform the exercises quicker and quicker. These are the wrist exercises that we have managed to complete. This set of exercises uses the accelerometer built into microcontroller, and there are 6 possible hand exercises that can be used to help the wrist, and these are the 6 exercises that we are capable of now tracking and monitoring. So the first step that you have to do is to set the patient ID. So as many number of patients as you have will have to be set up here. You can pick whichever patient you want. I'm picking patient 1, and you can also decide what is the current status of the patient when he came for the exercises, and which exercise do you want to do is the next option. So I'm selecting exercise 1, and I am also selecting the cycle duration that I have decided. It is also set at 6 seconds, which means that the entire exercise has to be completed within 6 seconds. So once I give the run command, the exercise will begin to get executed, and I should be able to see the waveform, and at the same time the graph will be plotted, and I will be able to see if the exercise was completed or not. And at the same time, the completion status will be logged into the cloud using ThinkSpeak IoT, and we will be able to see that data as well. So let's start this. I just have to click the run command for this. So as you can see, the exercise says it has been completed. The reason why it says completed is because the waveform that is expected out of this particular exercise, which is shown in red, and the one which is shown in blue is the actual exercise graph that we have got over the three axes of movements. So we can see that the person who's doing the exercise has consistently managed to do better when dealing with the completion of the exercise. Hence, the exercise is said to be completed. He has completed it before time. The red line that you see is the mean waveform that you have got after carrying out multiple trials. We have carried out about 30 trials for each of these experiments, and the mean waveform that we are getting for each of the axes is obtained from using a regression learner. We have used a Fourier series based learner to come up with this curve. It's actually a Fourier series curve fitting formula that we have come up with. So this is the result that we get from the graph. And at the same time, the data has also been uploaded to the cloud, which we will see next. Once you have completed the exercise and uploaded the data to the IoT platform, the next step that the doctor has to do from his remote location is to simply log into the ThinkSpeak IoT platform and just go to my channels. You can see this link here. So you click on my channels, it will take you to the channels that have been created for the patients. So I have created three different channels, one for each patient that is there in the drop down menu. So we had started the exercise for patient one. So let's see how the patient one's exercise log looks like. So this is what you will come up with when you click on that patient one exercise log. You have the channel view that you can set. Do you want it to be public or private? It has to be private because it has to be visible only to the doctor. And you can also select the channel settings, which will help you set the different aspects of the channel. For example, which fields you want to be included. So all these fields will be logged. You can see the timestamp, patient ID, exercise number, the duration of cycle, and has it been completed will also be logged in. So if you look at the data import export button, you can directly read the data in the form of a CSV file, which will directly give you the status of the patient in an Excel sheet. It becomes very easy for the doctor to have a look at as well. So we will just go into this. I'll just say call it patient one. It has been downloaded. So once it gets downloaded, I click on it. And you can see that I am able to now see the different entries. So we also will be able to know when this exercise was carried out. Okay. We also will be able to know how many times the exercise was done. So total there are 15 exercise cases that the patient has carried out. What is the patient ID? I am calling it patient 1. It could be any ID that the doctor decides to assign that particular patient. So this also anonymizes the patient in case a third party is validating or visualizing these results. The next field is what is the progress of the patient. So was it poor when he came? Is it improving? Is it good? Etc. Etc. And the next field is the exercise. Which exercise is the patient doing? So we have like 6 exercises. So we are just looking at 1, 2, 3, etc. etc. And then the duration, we have set the duration as 6 seconds. So we are seeing 6 here. It could have been 3, 6, or 9. So any of these three durations would be coming here. And then we have the status of the exercise. Was it completed or not completed? So the doctor can simply have a look at this and find out if the exercise was completed or not completed or partially completed. And then the follow-up actions necessary by the doctor can be carried out. You also have option to log the latitude and longitude of the patient. because the doctor is sitting at a remote location and the patient will be actually having the equipment with using which he is doing the exercise. So you may also need to have a log of the latitude and longitude, but that is disabled here. You just have to click a button um, in the channel settings to enable that. I will show it to you. So you can see here the latitude and longitude can be set simply here by clicking on this channel set show channel location. If you don't want to show channel location, just click on this, it will get disabled. So that is how you can remotely monitor a patient's progress using ThinkSpeak IoT. The system has also been integrated with the Pingpong game. You can see as we move the arm up and down, the Pingpong table will also move. And after a preset duration, here we have set it to 20 seconds. The reading from the accelerometer will stop controlling the action of the accelerometer and the Pingpong table, and you will be able to see the resulting waveform, which should be able to say how well you have been responding. The three axes you can see are now visible to you. Based on this, you can further track how the patient is performing. This game, interactive game, is mainly designed for the purpose of taking out the patient's anxiety and to make sure that the patient is comfortable while carrying out the exercise. So waveforms are anyway getting logged, so you will be able to track the patient's performance anyway.